BBC Sounds. Music, radio, podcasts.
Hello, I'm Tom Sutcliffe, and this is Start the Week from BBC Radio 4. Hope you enjoy the programme. Unless you're out in the woods as you're listening to this, almost everything you can see around you will have been manufactured, and almost every material you see and touch will have been modified in some way. And mostly, we don't think much about what was involved in making the stuff we use, or wonder whether what it's made of can tell us something important about our success as a nation. Not today, though, because for the next 40-odd minutes, it's all about the material world. Tim Minshall is Professor of Innovation at the University of Cambridge, and his new book is about the extraordinary complexity and fragility of the systems that make things in the modern world. With him are the distinguished chemist Bernie Bolkin, whose book The Material Advantage argues that it's not the possession of raw materials, but the knowledge of how to reshape them that gives a society a real competitive advantage. And Fiona Deer, co-director of the Restart Project, passionate about finding ways to make the things we manufacture last longer and do less damage to the natural world. I want to start with we're in the middle of a real-world experiment with supply chains, Tim. President Trump essentially kind of hitting the machinery with a large hammer. But some of the motives for what he's doing seem to match what you're talking about in your book as well. Do you find yourself in an uncomfortable position of agreeing with him?
I will choose my words very carefully now, but there is something fundamental that we need the ability to manufacture things. And the way the world has become ever more complex with ever more sophisticated supply chains that span the globe is presenting us with incredible opportunities to do amazing things, but it does rely on the free flow of goods to and fro. So I wasn't really going to comment too much on the tariffs. That's not my area of expertise. But this fundamental ability for a nation to make things is pretty important.
And to be able to make them relatively close to home.
Absolutely. It doesn't mean, though, that you have to keep everything domestically. It's that fine line. It's a very blurry line.
Bernie Bolkin, your book is all about competitive advantage between nations, which is clearly driving what President Trump is doing. What's your view on that?
I think that the important thing is not to just be able to talk the game, but to actually do the game. Because, for example, in 2023, Rishi Sunak, Ursula von der Leyen, and President Biden all talked about how their areas, countries, regions were going to be the leaders in advanced semiconductor manufacturing. Meanwhile, Taiwan has 68% market share, South Korea 18%. So unless you have the fundamental science and engineering establishment behind this, and I'd like to hear more from President Trump and others about how we're nurturing science and engineering to be able to make these things in the long term. It's just talk.
But it's a blunt instrument for forcing that market into a different place, isn't it? And generating the investment.
Absolutely. And mobilizing the capital to do this and encouraging the entrepreneurship, those are all part of it.
Fiona, do you see any silver lining in this? In this chaos, in this moment of chaos.
I'm in a similar level of discomfort about agreeing with Trump here, but I do agree that if things are manufactured closer to where we buy them, you're more likely to have the skills that mean that companies can repair our products, and we're less likely to have these frustrating situations that we all have where something breaks, you go back to the manufacturer and they say they can't do anything about it.
Yeah, well, we're going to come back to that in a moment. Tim Minshall, I want to start with you and your book, Your Life is Manufactured. You talk in it of 4 industrial revolutions. The first is standardisation, kind of the French arms industry in the 18th century. And then Henry Ford comes along and adds kind of production line methods and so on. What's the third revolution? Because the third and the fourth are the really kind of significant ones for us now. What's the third?
Yeah, so the third was the application of computing power. So as we moved from giant valve-based computing systems which could do huge calculations down to transistor-based systems and then down to semiconductor microelectronic-based systems, this power, this democratization of computing power, had a fundamental effect on all of manufacturing. So that was one part that came in. It's broadly under the heading of automation, because it allowed us to automate some of the more mundane cognitive tasks. But it also brought in robotics, industrial robotics. We saw computing power and we saw robotics coming in. The fourth industrial revolution, arguably, well, it's one for discussion. Is it a continuation of the third one, or is it something different? We can debate that.
Well, the way you put it in your book is you ask whether it's a highly caffeinated form of the third revolution. I wonder what you meant by that.
Well, it's an extension of. So whereas perhaps under the third revolution, the computing power was largely machines, processors at specific locations doing a specific thing. As we moved with the power of the internet and now the power of machine learning and all of these things, and of the Internet of Things, and specifically the industrial Internet of Things, where every single device, when it's being processed, when it's being made, when it's being distributed, when it's being used, is generating data. That gives a phenomenal amount of resource that can be used to make better products, use them more efficiently, use them more effectively, and keeps data in them so that when they need to be repaired, we know how they've been used. So it is very much I would say, in that context, an extension of the third revolution, but it is extremely caffeinated.
One of the themes of your book is the increasing invisibility of making in our society. That we start and, the factory would be round the corner. You would have a notion of how a thing was made and kind of understand its processes. And those have increasingly become invisible. Now, that's for two reasons, isn't it? Both of the kind of factories have been dispersed, but a lot of the making has gone overseas.
Yes, there are great benefits there have been some great benefits to globalisation. These things are always a double-edged sword. We see amazingly good things happening and distribution of wealth around the world, but it has created a number of problems. I should just state at this point that I'm not advocating in some rose-tinted way that we go back to pre-industrial revolution times. That's not, I think, what we're here to talk about. Fundamentally, our world is manufactured and will continue to be manufactured. We just need to find a way to do it more effectively and a less harmful way, because it is, as Bernie says in his book, it's the manufacturing that will deliver the science and technology to solve the big problems.
Carry on.
I was just going to say that this invisibility, you could say, well, it doesn't matter. There are many elements of life that are largely invisible to us. The sewage system, we want it to work and know it's there. We don't particularly, I'll leave that there. But the manufacturing system, the more we become disconnected from it, the less we appreciate what's going on. And as you said in the introduction, Tom, this complexity, the levels, the nodes in every network for making something as like we have in our pockets or bags, a mobile phone. There are thousands of companies involved in that. And the further and further and more complex it becomes, the less we understand what's going on. And that has three problems I'll just mention very quickly. One is we don't realise, and I will say we, because everybody is involved in manufacturing whether they know it or not, it's become very fragile and very lacking in resilience. And we saw that during COVID. The second problem is it's led to some dramatic inequalities because we don't see what's going on. We don't know some of the less good things that are happening perhaps far away. And then the third one, which I know we're coming back to later, is this issue of sustainability. This incredible system we've built for dealing with the base of Maslow's hierarchy. It provides us with food and with shelter and with clothing. The making of those things is phenomenal, how we've done it. And yet at the same time, the way we're doing it is slowly destroying the planet. But there is good news, of course. We are getting much, much better at this.
I'm glad there's some good news.
We'll come back to the good news later, perhaps.
You quote Turankan Salua, who set up Getir, which is this service, that just will bring you a banana from the local shop and deliver it to your house, which is one of these third industrial revolution developments of data. He described it as democratising the right to laziness. It's democratising the right to have serfs, isn't it, as well? And there's always a social downside to many of these developments.
Yes, and that company is one of many with a similar business model where you need to have things operating at scale, and the extraordinary power of the third/fourth industrial revolution to do amazing things. And in the book, I do that as an engineering exercise, work out how that pizza arrived at my front door and the technologies required to make that happen. It's phenomenally clever and it's just absolutely brilliant, but it still relies on an individual weaving their way through pothole, dark, rainy streets to deliver me the thing I want because I'm too lazy to go out. Now, that doesn't mean that we shouldn't have super efficient supply chains for doing other things. So it's very easy to just say, oh, we don't really need that, let's not bother. Actually having super sophisticated supply chains right down to the last mile, the last 100 metres, can be very useful in the world of, say, healthcare or security and defence. But sometimes that we always package it up and say it's laziness because you don't really need that avocado or that banana if you plan properly.
But the fragility of that very complicated system is the problem, isn't it? You write very interestingly about COVID, which was another illustrative shock, which kind of broke many supply chains. There was some good news there, wasn't there, as well?
There was. So we looked at how the healthcare system nearly collapsed. So I work at a place called the Institute for Manufacturing, which is part of the engineering department at Cambridge. And there is a huge teaching hospital in Cambridge, Addenbrooke's Hospital, and it faced, like all hospitals did, an extraordinary range of near existential crises during COVID. And so we were very privileged to be able to help in a modest way with this. But there were sort of three bits to it. There's the operational side, running a factory and running a hospital. There are parallels with this, so there's an operational bit. But then there was we can't get face masks and surgical gowns delivered because they're typically made at the lowest price point and imported from overseas, very often from China. Quite understandably, China had its own problems during COVID and didn't export them. So these didn't arrive. But we saw the development of local manufacturing, but it was kind of in a panic mode. And it was done in some places very, very well. In some places, it didn't work that well. But we've tried to look at it and said, well, what was good about that? What can endure beyond a pandemic? And we're very interested in now looking at, well, has that changed the nature of local skills for manufacturing? If this happened again, could we do that?
Can it happen? I mean, it was striking. Britain went from making 5 ventilators a day to making 400 a day in quite a short period of time. And that's a very complex machine with very kind of complex requirements about how you make them and the quality.
Absolutely. And maybe many interesting points about that, what was called the ventilator challenge. And I know similar in the US, there was great schemes like Operation Warp Speed, which was doing things for vaccines, and incredible crisis-driven, adrenaline-driven solutions were developed. But what we're intrigued about is, well, what can we learn from that? Can we take a drug development process that normally takes 10 plus years? I mean, for the vaccine, it was compressed down to almost nothing.
Yes, I mean, I was going to ask you talk about good manufacturing practice rules, both in vaccines and for medical supplies, which are very, very stringent requirements so that things are safe. Yes. Were those loosened during the COVID emergency, or just people found new ways to apply them?
They were definitely not loosened. What happened is a different approach to risk was taken, not patient risk and safety. That's absolutely untouchable, quite rightly. The risk came on the financial side. So rather than waiting for phase 1 to be done and test and make sure it's absolutely passed through the first phase, and then you raise some more money and do the next thing, and then you faff around and do some more raising money and do the next bit, you said, we assume that 2 and 3 are going to be successful, are going to be needed, so let's get them started. So when something was successful, it went sort of like very, very rapidly through all stages. So it wasn't in parallel, it was slightly offset parallel rather than being in series.
Now, clearly people are prepared to risk money in that way if there is a crisis.
Yes.
You work in the venture capital world, Bernie Balkin. They're less likely to do it if there isn't a crisis, aren't they?
True, but there is a history of doing these things with materials and manufacturing in crises, of course, which is wars, world wars. At the beginning of the First World War, the paper manufacturers, who had not very long before, Tim talks about this in his book, started making paper from wood pulp, because before that, all paper was made from rags, the biggest recycling, repurposing program in history until the last 25 or 30 years. So paper manufacturers, at the beginning of the Second World War, they knew everything about how liquids were absorbed and bound to paper products. And one of the guys in a lab, Kimberly-Clark, I think, started fiddling around with this, and he came up with the idea of bandages. Because before that, bandages were cotton cloth that was wrapped around. And he made a very super absorbent form of cellulose, wrapped it in gauze, which is also cellulose, cotton, and then made bandages, which were a crucial thing for World War One. I'll come back to it in a second, but the same thing happened at the beginning of World War II. DuPont had just invented nylon, and nylon stockings became available for the first time in 1939. They quickly took 30% of the market. But then when the war started, everything turned to how do we get the products we need that we're relying on Japan or areas that would be conquered by Japan for supply. And one of those was silk for parachutes. So silk was the essential thing for parachutes. Well, it turned out they stopped all production of nylon stockings. Very easy to make large sheets of nylon, and it turned out to be perfect for parachutes. So again, the crisis led to the change, and people did invest in it.
Your book is about exactly that sort of jockeying for kind of advantage. It's called The Material Advantage. You're not talking about raw commodities, are you, in the book? You're talking. You have a different definition of what a material is. Can you tell us what it is?
Yeah. So, raw materials are things like ores or crude oil or whatever. If you have a lot of raw materials, usually you just get exploited. That's the history of the world, and it continues to this day.
We see it happening in the Congo, right?
Exactly.
Right now.
Across a lot of Africa. If you have the science and engineering and entrepreneurship and capital to transform raw materials into manufactured materials, then you have something valuable and you can get competitive advantage. And that competitive advantage can happen in many different forms. So I mean materials that are manufactured rather than raw materials. And in fact, economists will tell you that producing raw materials doesn't increase national wealth, because all you do is you sell something and you reduce the stock of what you have under the ground. So you're in the same place.
If they're above the ground, it's slightly different, isn't it? You write about England and the wool trade.
Right.
Now, our possession of sheep that could grow a certain type of wool did contribute to our economy, even when we were sending it abroad. Isn't that true?
Absolutely, because first of all, the sheep are interesting because both English sheep and merino sheep in Spain were a 300-year research program, selective breeding. If you look at pictures, there are paintings of sheep from the 1200s where they have very little wool. And then you look at merino sheep today, they have to be sheared practically every day.
So you count that as a manufacturing process, do you?
I count that as a research project the sheep farmers didn't know about Darwin, but Darwin actually knew about the sheep farmers. He knew about selective breeding. So, sheep to wool and then wool to garments was a tremendous thing for England, and so was, after that, cotton. Yes, a lot of it
But it's that moment at which we bring the processing of wool back on shore, instead of just sending it away to be processed and make textiles, is a step change in the economy.
Absolutely. So the wool was being manufactured into garments in Belgium and Flanders and places like that. It came on shore. Cotton was just that, which was the next chapter in the Industrial Revolution story, was just the opposite. We've never grown a single cotton plant in Britain, and we couldn't grow cotton in Britain. The climate is all wrong for it. But for 2 centuries, we dominated the production of cotton clothing.
And indeed impoverished India because we took steps to ensure that they could not process
Exactly. We forced the deindustrialization of India, exploited the American South, which could have built cotton mills, but didn't do it until well after the Civil War. So we brought cotton manufacturing here, generated tremendous amount of wealth from the export of cotton, used all of British engineering and ability to mobilize capital and entrepreneurship to build these big mills, dark satanic mills, some have called them, but to build these big mills, and generated vast amounts of wealth, which we were able to use for other things.
You were talking about paper earlier and about the application of paper at the beginning of the First World War, but it's a crucial chapter in your book, the Abbasid application of paper. Now, as a schoolboy, I'd always thought the Chinese invented paper. Why did they not get the advantage that the Abbasids did from it, as you argue?
It's generally accepted that paper was invented in China about the year 100, 150, the Common Era. The Chinese loved to keep things secret. They had kept how silk was made secret on pain of death. If you told anyone or left and tried to tell you, it was a capital offense. So they kept paper secret. They didn't scale it up. They could make 1,000 sheets a month, maybe the most. The legend has it that when the Chinese and the Muslims caliphate were fighting for control of Central Asia in about 750, there was a battle between the Chinese and the Muslims at Talas in what is now Kyrgyzstan. May have been Kyrgyzstan then, for all I know. A bunch of Chinese prisoners were captured. And they were told, you'll all be executed tomorrow unless you can teach us something interesting. One man put up his hand and said, I know how to make paper. Well, we can imagine the dialogue that ensued after that. But whether it was that way or more gradual evolution, the Abbasid scaled up the manufacturing of paper in Baghdad, in Egypt, in Samarkand. They built places, effectively factories, to make large sheets of paper and huge amounts of it. And from that, they made books. They started translating the ancient Greek and other manuscripts of countries that they had conquered. They revived all the mathematical ideas, all the medical ideas that had been lost. And as a result of this, there was the greatest increase in literacy and numeracy that the world had known up to that point. It was an amazing triumph, and it's what led to what is called the Islamic Golden Age.
Yeah, from about 750 to about 1250.
Exactly.
I mean, an extraordinary rich period.
Spread from Central Asia all across down southern Europe and effectively, ultimately in Spain and Portugal, which was a great place for the Islamic Golden Age, and many great works were done there.
It is interesting that transmission of the knowledge of how to make things. That's the crucial thing, isn't it? That once you have the technological knowledge, then a kind of variety of applications can emerge from it.
Absolutely, and there's this idea of, similarly back to Middle Ages and earlier times, of common land, where communities would say, well, this thing we've got is good for all of us and we must all maintain it. That logic also applies to manufacturing. We talk about the concept of industrial commons. Do we have the skilled people? Do we have the capabilities to make things? And you can't just switch that off and on. And through history, we've seen it build up, and sometimes technology has changed and we no longer need that thing and things die away. But very often, we realise we do need to keep this base level of manufacturing going.
Yeah, Bernie, you wanted to come back on that?
Well, one of the most famous examples of this, which is talked about in the book, is how the Romans were great engineers, of course, and the Romans learned how to make concrete using pozzolanic sand ash from Vesuvius and Etna. And then the whole technology for how to make concrete was lost for 1,000 years. People could look at the Pantheon and could not make the concrete to do that again until old Roman manuscripts were found with the formulas by Vitruvius, and it was revived.
You can't reverse engineer it chemically, can you, by chemical analysis? You needed to know how they started.
Certainly you couldn't do it by the chemistry that was available in 1400.
Aren't some elements of progress essentially technological and not material at all? I mean, electricity, for example. It doesn't matter whether it's made with oil or gas or sunshine. That gives a society a huge competitive edge. How are materials involved in that?
Well, why do I have a chapter on electricity in this book? Because how do we transmit the electricity from where it's generated to where it's used? Well, you see these big transmission cables. If you look at the very first ones that were built, there were poles every 40 feet. Now there are poles in the big transmission systems 1 kilometer or even further apart. Why? Because we went from copper to aluminium. We sacrifice a little bit in conductivity, but it's much lighter weight and easier to string, and you don't have to have so many poles. So that transmission is a material story, and it's one of the reasons why we don't have electricity grids in Africa, because the big aluminium companies that are selling this transmission cable and doing all the technical support for it, they're not even operating in Africa. So we don't have transmission grids there. Goes back to the empire, but there's a lot of materials involved.
Tim?
I just briefly say, but to me, the power generation is one of the most, as you say, one of the most fundamental manufacturing needs of any nation. And we're certainly seeing that at the moment. One of the greatest challenges for our manufacturing systems is, can we manufacture the power systems that will give us everything else we want?
One of the kind of regular assumptions, a kind of received opinion, is that Britain is no longer a manufacturing nation, essentially, that we provide services. Do you think that's true?
No. I can expand on that a little bit. Yeah. So 2 reasons. One is we have changed the way we measure what manufacturing is. Back in the day, we'd have large, very vertically integrated corporations where everything was done, and if you worked for, say, BP or Jaguar or whoever it was, you would be classed as working in manufacturing, even if you were working in distribution or catering or wherever it may be. Those jobs have typically been outsourced now, so the number of people who appear to work in manufacturing has reduced. Now, we've also become more efficient, we've become more productive at manufacturing, so the actual running of a factory in a richer country requires fewer people. So yes, we see less people involved in it. It has not diminished its importance.
That's part of the invisibility, that
Exactly.
Our neighbours aren't kind of going off to the factory in the morning because there are less people working there.
Exactly so.
You write in your book, towards the end, certainly, about kind of the sustainability of manufacturing. A lot of words beginning with restart, recycling, all sorts of things, reuse and restart. I said restart because that's what you run, Fiona. Tell us about Restart. What is it?
Well, we are trying to help keep products in use for as long as possible. And there's lots of ways that we need to do that, because there's lots of ways in which it's really hard to keep our things in use. So we started with by running community events, which lots of people know as repair cafes, but kind of volunteer-run events where you can just bring a broken product and somebody will help you fix it. And hopefully you get to learn a bit about fixing along the way. And they're incredibly popular, and they've just grown massively in the last few years. There's more than 600 now in the UK. And they're an absolutely brilliant thing, but there's only so much you can do at the end when you're facing this tidal wave of waste coming at you. So we also campaign and try to kind of change the system so that we can have a much more thriving repair economy, because at the moment, it's hard. It's really hard to repair. And there's a lot of things that we could do to make repair easier.
Where do we stand in terms of electronic waste? Are we an unusually wasteful society?
We are. With the UK is the second highest producer of electronic waste per person in the world.
And that is a case of just us moving on, that our devices become obsolete. I can't be the only person here, listening to this, who has a drawer full of old phones.
That everyone has a drawer full of old phones. We've kind of, there's been a slow creep towards a throwaway economy that we're in. So that it happens at every level. The products that we're sold don't last as long, and we've got out of the habit of thinking about repair. So normally, if something breaks, you think, where can I get a new one? And if maybe there'll be an afterthought that's actually maybe I can get this repaired, but then you want to get something repaired, and it's actually quite hard to find where to do that. There's some exceptions. So white goods like fridges and dishwashers, and also tech like phones and laptops, they're actually fairly healthy industries that can repair those products because they're high value. But the poor toasters and kettles that are stuck in the middle, it just doesn't make sense to repair them economically.
There's a catch-22 though, isn't there? Tim has kindly brought in sort of, 3 very widely dispersed generations of mobile phone here. The first is the size of 2 house bricks, at least. Nobody is going to be, when the kind of little Nokia comes along, nobody is going to be saying, just keep this going, are they? So technological progress is part of the problem with waste, isn't it?
It is. I mean, the older phones tend to be more repairable, and one of my favourite examples to bring to life how unrepairable things are now is anyone who's older enough to have had an old Nokia will be familiar with flipping out. If you needed to change the battery, you'd flip it out like you would with a lot of other products. Now, it's a full-on repair, and I discovered this about a week into starting work at the Restart project and had to take my phone apart. Luckily, I had access to a skilled person because through my work, and someone was able to show me how to do it. I then had to order the battery and do it at home. I was able to borrow tools from work, but most people can't do that, and it still took me about 2 hours and a lot of fear because I had to use a hairdryer to melt the glue, and that's just not something most people are going to do.
There are things. I mean, Tim again writes about the processor in his newest computer, kind of Max M3 Pro, I think it is. I've probably got the title in the wrong way. 92 billion transistors on that microprocessor. That's been made in a sort of factory with, kind of level 1 clean room. You're never going to be able to repair that, are you? And isn't that...
I'm not going to get into that level of repair, and most people aren't, but there are things that break quite quickly if we stick with phones. Your battery's going to run low, or you're going to need your screen replaced, and they're both incredibly hard things to fix. But what's frustrating is kind of going back to the manufacturing and the supply chains involved, is if you look at the life cycle of a phone from kind of the materials being taken out of the ground to waste, and you look at the carbon emissions during that whole process, 80% of them are produced before you even get the phone in your hand, before you get it out of the box. And actually, Tim's book really brings to life why that is. I mean, the materials that are in our phone have gone around the world several times. But so when you look at that and the amount of energy and material that's gone into making a phone before we've even used it, we really just need to keep them going for much, much longer. We can't be throwing them away every few years.
There are kind of complicated solutions. Before I come to those, at the consumer level, you have ways of kind of tackling the affordability question. My dishwasher breaks. Somebody comes around and says, well, I can repair it for £350, or you can buy a new one for £430 and it'll come with a 5-year guarantee.
Yes.
It's difficult to get past that, isn't it?
This is one of the biggest contradictions. We've all had that example of being told by a repair person that we should just buy a new one, and it is about cost. But
so what are you going to do about that?
So we are going to be trialling a repair voucher scheme later on this year in London. There's some brilliant examples of how that's worked in Austria, where it has driven up, obviously, rates of repair. Just to row back, the way it works is that you get 50% off the cost of a repair when you go into a repair shop. The customer gets the discount up front, and then the repair business claims for it. So it's really easy. It just gets people into repairing, and even after the trial finishes, we expect to see repair rates stay high because it's getting people into the habit of it.
People know that service is there, and they know they can use it.
Yeah.
Who pays for because
in our case it's a trial that's being funded by North London Waste Authority, and there are a few other examples of how that gets funded. In Austria it was funded by a COVID grant, but there's an example in France where it's paid for by extended producer responsibility. So that's where manufacturers have to pay into a scheme that usually just goes into recycling of their products, but actually this is being diverted to helping people repair. So it's a much more progressive way of doing it.
So it is in itself sustainable, as it were. You can find a way to make it economically sustainable.
Yeah, and that's essential, of course.
The other element that's interesting is you want to make consumers better aware of whether they can repair a thing before they buy it.
Yes, and again, I'm going to go back to France. They have a brilliant repairability index. So it's a bit like the eco ratings when you buy a washing machine, but you can see at point of sale how repairable a product is. And unsurprisingly, it has shifted what people are buying. People are going for the more repairable products, and that has had a knock-on effect. That's now an incentive for manufacturers to make products more repairable. So that's what we need. But the other benefit of it is that it's a really important message that consumers are getting, that a lot of people think that once the warranty has run out, that actually you should probably think about getting a new one. But that's not the case, especially if you look at something like a washing machine where it could last for 15 years, but the warranty or the guarantee is 3 years. But actually, if there's really clear labelling about repair when you're buying a product, then they're more likely to think about repair later on.
Yeah. Bernie Belkin, you write towards the end of your book about dematerialising the world. Are you partly talking about things like sustainability in repair, or is it just a case of making better materials?
Well, partly talking about using less when it's possible to use less, because we had to before we got to electric vehicles, we went through a long period from 1973, the first oil shock, until really 10 years ago, where we had to reduce the weight of vehicles in order to improve fuel economy. And a whole lot of taking out weight was done by taking out materials or putting in lighter materials. And that's crucial. And we can still see lots of opportunities.
I was going to ask you, is there still room for improvement there in terms of material science?
Absolutely. Absolutely. We can, and there are ways of using less and there are ways of reducing waste, because part of dematerializing is not producing waste which you don't have to produce. Both Tim and I talk about 3D printing, which we better called additive manufacturing, because you're building it up rather than subtractive, where we start with a block of something and carve it away, and what's falls away is waste. Another is tremendous amounts of waste in construction. Look, we're talking about massive home building projects in the UK now, need for building hundreds of thousands of homes. Anyone who's been to a home building site has seen the skip with all the piled up wood and other materials that were that were ordered, paid for, and not used. And we don't want that to go to recycling. We want to use less of that. And some of the computer tools that we have now allow us to do this much, much more efficiently.
Yeah. Tim?
It's a lovely example also of going back to what we were saying earlier about crisis-driven innovation. The oil shock of the 1970s was a pandemic-like thing. Suddenly, we needed to make things that were more efficient, and lo and behold, we could produce products that were like that. The other issue, I guess, is that manufacturers want to be more efficient, because they're more efficient and waste less, they make more money.
Yeah. So you write very interestingly about British Sugar, who process. I mean, it's kind of in technological terms quite a crude process, isn't it? They're taking in sugar beet, muddy and so on. They began to wash the sugar beet, and they now sell the mud that they wash off the sugar beet.
Well, indeed, as Fiona was saying earlier about the move to the circular economy, this is a lovely example of that. It's a very specific one, but there's great lessons from this. So yes, sugar beet arrives in thousands of tons during the campaign when they bring it all in and do a lot of chemical and heat and mechanical processing. But mud on sugar beet was just chucked away. Stones were just chucked away. But they took this concept of saying, we can create another value stream from this. It is not waste. It is actually a valuable product for someone else. We just need to make sure there's a market for that. And so topsoil, rich fenland soil, very, very good. Rocks, perhaps less so, but still usable. But then all the way through the process, they looked at every single stage and said, why is there something called waste coming out of this? Can we do something with it? Just a couple of quick examples. They had their own power station. They had producing too much power, so they then said, well, we can make that available to the local community. Then we had the plant generates a lot of heat and CO2. Well, great use for CO2 and heat is to pump it into greenhouses. So they had to find a partner who built huge number of greenhouses, and they ripened tomatoes there. Absolutely brilliant, until the market dropped out of the tomato market, and so they had to find another product, which turned out to be medicinal cannabis. So all of these things, right the way through to the production of the waste products leading to bioethanol. So when you fill up your car with E5 and E10, some of that has come from sugar beet processing.
Bernie, you wanted to come in?
Wood waste is a very good example. I remember being on a panel with somebody from IKEA, and someone was talking about wood waste to energy, and he said, the IKEA guy said, there is no such thing as waste wood. We can make a Billy bookcase out of anything. And they, by using what somebody thought was waste to make a valuable product, they made a business.
The only problem with the Billy book is that they're quite difficult to repair. Sorry, Fiona.
Well, no, I was just going to pick up on both of you have said have used brilliant examples of how you can keeping things in its in its most complete form is the most efficient way of doing things. So you could chip it, or you could chip it up in the case of the Billy bookcase. But if you can keep the wood, or if you can keep everything involved in producing sugar beet in the form, in as close to its original form as possible. That's the most efficient thing, and that's where we get frustrated with it. There's such a focus on recycling, which is great for things like glass and tin and paper, but for electrical products, which we work with, it's really wasteful. So we found out that we've looked through an electrical waste bin and found out that almost half of what's been thrown away was either still working or really easily repaired, and we need to keep that in use.
I want to ask you all one last question. We're coming to the end of our time here.
Yeah.
This would seem to challenge that great fetish of governments of all complexion, growth. How does growth survive in a society that says, no, I won't buy a new one, I'll repair this one?
Well, there are good examples of the growing market in second-hand mobile phones, and there are some real kind of trailblazers who have just got us to think differently, and so I think that there can be economies around reusing and repairing.
Bernie, you were smiling. I don't know whether you thought that was kind of fanciful or...
No, not at all. I'm just smiling because I'm happy. I think there are so many opportunities, so many things that we need to do, and that science is offering us the possibility of doing differently with new materials, that growth is not a problem. All we have to do is invest capital and invest in our science and engineering base, and we'll have plenty of growth.
We don't have time, Tim, to hear your views on this, but I expect that's music to your ears. Thank you to all of my guests. Fiona Deer, co-director of the Restart Project. Details of their repair days around the country are on their website. Bernie Bulkin's The Material Advantage is out now, and Tim Minshall's Your Life is Manufactured is published on the 13th of February. Next week, Shahida Bari looks back at the 70s campaign, Wages for Housework. But for now, thank you and goodbye. Thanks for listening to this edition of Start the Week on BBC Radio 4, produced by Katie Hickman. And if you're after more conversations on art, science, history and politics, you can find many, many more on the BBC Sounds website.